My topic was absolute value, and so we started out by reviewing the basic absolute value rules. Number one being that a negative value within the absolute value notation becomes a positive. And the number two rule refers back to number one because all absolute value products must be greater than or equal to 0. But number one saying that any negative number becomes a positive number is ensuring that all numbers are going to be greater than or equal to 0. For number three, the products of two numbers multiplied in separate absolute value notation is going to have the same product when put into one absolute value notation. And it is the same for division, except the quotients are going to be the same. For a power, any number to a power outside of the absolute value notation is going to be the same as if it were inside the absolute value notation. In the video for number one, I am showing that a negative 3 is equal to a positive 3 in absolute value notation. Number two is showing that the 3 is greater than or equal to 0. For 3 and 4, I'm showing that the quotients and products are the same multiplied inside and separately for the absolute value notation. And for number 5, I am showing that a number to any power outside of the absolute value notation is the same as inside. Next is the topic of solving absolute value equations. And the rules for that is, number one, you are going to rewrite your equation as two separate equations. One will be positive and you make the other one negative. And after you've solved both of those equations, you're going to substitute the answers that you got back into the original equation and make sure that your solutions are valid. And then once you find your valid solutions, you're going to write them out. For the video of this one, the example is 8.4 minus 2n plus 5 inside of the absolute value notation, n being a negative 7.5. And since it is a negative number of 7.5, it's going to be a negative inside of the absolute value notation, which will become positive and leading to a positive product. Next is solving absolute value inequality, and the rules for this are the basic signs is what you're going to start off with, which are less than, equal to, and greater than. For the addition property, if the A is greater than the B, then the sum of the A and C is going to be greater than the sum of B and C. So two greater than signs. And then if A is less than B, then the sum of A and C is going to be less than the sum of B and C. So two less than signs. For subtraction, if A is greater than B, then the difference of A and C is going to be greater than the difference of B and C, so two greater than signs. And then if A is less than B, then the difference of A and C is going to be less than the difference of B and C, two less than signs. For multiplication, when C is positive, and A is greater than B, then the product of A and C is going to be greater than the sum, or the product of B and C. So once again, two greater than signs. And if A is less than B, then A and C's product is less than the product of B and C. So two less than signs. But that switches around when C is negative, because when A is greater than B, but C is negative, the product of A and C is less than the product of B and C. So they're two opposite signs. And same for A being less than B, A and C's product is going to be greater than the product of B and C. For division, it is the same. When C is positive and A is greater than B, then A and C is going to be greater than the quotient of B and C, so it's the same sign. And then if A is less than B, then the quotient of A and C is less than the quotient of B and C. Once again, the same sign. But where it is negative and A is greater than B, then the quotient of A and C is going to be less than the quotient of B and C, making it two opposite signs. And same when A is less than B, and then A and C's quotient is going to be greater than B and C's quotient. In this video, For the addition portion, I showed that b plus 6 is less than 14, so I subtracted 6 from both sides, and b is still less than 14. Or 8, sorry, b is less than 8. So then for subtraction, y minus 6 is less than 3, and I added 6 to both sides, making y less than 9. The signs don't change on either one of those, but when you get to multiplication, the example was negative 4.2 times x is less than or equal to negative 29.4. So I divided negative 4.2 from each side, and since it's a negative number being divided, the sign is going to change, so it's going to be x is greater than or equal to positive 7. And then for division, the example was negative w divided by 4 is less than or equal to negative 7. So I multiplied each side by a positive 4 from the bottom, and it's going to be negative w is greater than or less than or equal to negative 28. Dividing by a negative sign on each makes the sign switch, so w is greater than or equal to negative 28, or positive 28, because the negative goes away. Next is graphing on a number line. So when you graph and you have an equal to, greater than or equal to, or less than or equal to, you're going to have a closed circle on the number line. But if there's no equal to and it's just greater than or less than sign, then it's going to be an open circle on the number line. So after you've drawn your circle or shaded it in, you're going to shade the part of the line in which all the values are included as solutions. So in the video, I used the examples from the previous examples, the answers from the previous examples, and number 1 was b is less than 8, so there's no equal to sign, so it's open and pointing towards the way the arrow is going, so to the left. Same for number 2, except open circle on 9 and pointing to the left. But when we got to 3, it was a greater than and equal to sign. So then the circle is going to be shaded in and pointing to the right. And for number 4, it was the same thing, greater than or equal to, shaded in and pointing to the right. And that was our topic of absolute value. Thank you for watching.